So please see this figure now. So this is a slab panel, one-way slab panel we can see, and in this one-way slab panel you can see that the shorter span is of dimension 3.5 meters and longer span is 7.5 meters. We are abbreviating short span as LX and longer span as LY. Main reinforcement in one-way slabs is to be provided along the shorter span as I have shown here, main reinforcement. Perpendicular to the main reinforcement, we provide distribution steel or distribution reinforcement. So let us see few clauses. What are the guidelines by IS 456? Indian Standard Code of Practice 456/2000. What are the guidelines for minimum steel to be provided in one-way slab? So if the steel grade is Fe250, Fe250 means mild steel. For mild steel, minimum steel is to be provided is 0.15, right? 0.15% BD. So this is your width and this is your overall depth. So overall depth is equal to effective depth plus effective cover. Now let us assume that the overall depth is suppose 125 millimeters. 125 millimeters is your overall depth. So in case of Fe250, it is 0.15% of BD, and if it is high yield strength deform bars like Fe415, or if it is Fe even 500, Fe415 and Fe500 comes in high yield strength deform bars. The minimum steel is to be provided is 0.12% of BD. 0.12% of BD. Now we always we have to follow these guidelines. So this is the guideline to provide the minimum steel reinforcement in one-way slab. Now minimum diameters to be provided. Generally in practice, in distribution, as a part of distribution reinforcement, generally in practice 6 mm dia bars and 8 mm dia bars, depending upon the load on the slab, load intensity on the slab, which generally ranges in residential buildings from 6 to 7 kilonewtons per meter square. Distribution steel is provided is generally 6 mm dia bars, 8 mm dia bars, and as a main reinforcement 10 mm dia bars, 12 mm dia bars, and so on. These are the diameters generally provided in practice in slab panels. Now you assume, as we have seen in our previous lectures, that how to calculate the loads, and then after the calculation of loads we calculate the steel. In case of beams also we have seen. Now if we will assume that the steel you have calculated, suppose 450 millimeters square. You can watch my previous videos how to calculate the steel. Now you have calculated 450 mm square steel, and now you have to provide the steel reinforcement in one-way slab panel. So you have to design this one-way slab for 1 meter. 1 meter means 1000 millimeters. So the formula which you will be using to calculate the spacing of reinforcement or spacing of bars, spacing is equal to, now see this, the distance between two bars, this is known as spacing, S, is equal to 1000 into pi by 4 into d square. D, or I am abbreviating it by phi, means diameter of the bar square. I am trying to calculate the spacing of held strength deformed bars main reinforcement upon AST. Now simply you decide, suppose you are providing 10 millimeters dia bars as a part of main reinforcement, then you substitute here the value 10 in case of diameter, 10 millimeters, and AST you know it is 450 millimeters square. So you will get the spacing for 1 meter length of one-way slab panel. How much it is coming? Can anyone calculate?
So 697.8.
Okay, no, please calculate again. It is coming 180.45. Please calculate properly. 180.45 millimeters. Center to center. It is the spacing. Pi by 4 is 0.785, na? 0.785.
Yes, sir. 180, sir.
Right? It is coming around 180.45 or 180 point something. It's okay. So you are getting now the spacing as suppose 180.45. Now you have to see the clauses, you have to refer the clauses mentioned in IS 456 for minimum spacing. So if in case of slabs, when it comes to main reinforcement, you have to calculate, see, now the overall depth is suppose 125 millimeters. In my previous lecture I have explained you how to calculate the effective depth also. Now effective depth is equal to overall depth minus effective cover. Suppose 25 mm is the effective cover. Effective cover is suppose 25 millimeters. Then overall depth minus 25, that is 125 minus 25 millimeters, your effective depth will be 100 millimeters. Now if effective depth is 100 millimeters, now what are the criteria for minimum spacing to be provided? The first is 3 times effective depth. 3 times effective depth means 100 multiplied by 3. It is coming 300 millimeters. The second criteria is 300 millimeters. Now, In this case actually same value we have obtained. If there would have been 300 and 270, you have to select 270. You have to choose minimum of these two. So 300 millimeters you have chosen the spacing. As per the IS code of practice, you cannot provide more than 300, right? Now your spacing is 180, so it's good. You try to provide in the multiple of 5 or 25. That is, you provide now 10 mm dia bars. This main reinforcement I am talking about. 10 mm dia. So this is HYSD steel Fe415. So torque 10 mm dia bars at the rate, you don't provide more than 180, 185 don't provide. Calculations you have got 180, so provide less than that to be on safer side. 175 mm center to center. So it should be in the multiple of 5 or 25. In this way you have provided the steel here in one-way slab panel as a main reinforcement. Now let us see the distribution reinforcement. This is Fe415 0.12% PD. So 0.12 divided by 100 into B, you have to design for 1 meter. See, along the longer span it is 7.5 meters, right? So in one-way slab panel whatever we design, that is for 1 meter. So the distribution reinforcement will be 0.12% of BD. B you have to take 1 meter. 1 meter means 1000 millimeters, because you are designing one-way slab panel along the longer span for 1 meter always, into capital D, it is 125. So how much it is coming? Can anyone calculate? This is 0.12%. So divide by 100. I think 150 millimeter square.
Yes, sir, 150.
Now 150 millimeter square is the steel reinforcement you have to provide, but this is for the distribution reinforcement. And remember well, when we design one-way slab panel, for main reinforcement we are taking the span, but for distribution reinforcement we are taking for 1 meter length. So now 150 millimeter square is your distribution reinforcement. Now what are the criterias to design your distribution steel reinforcement? So first of all, you decide now the diameter of the bar. Suppose you have decided that you are going to provide 8 mm dia bars, 8 mm dia bars as a distribution reinforcement. Now you try to calculate the spacing for the distribution reinforcement. So spacing S will be equal to 1000 into pi by 4 into, you have decided the diameter as 8 mm to be provided divided by AST, that is 150 mm square for distribution steel. Now you tell me the spacing. Pi by 4 into 8 square. Generally 8 mm diabar, area is 50. How much you are getting? 333 point something like this. 333 point something you are getting. Yes.
So where did we get the 8 millimeters?
333 point something.
Yes, sir. 2-3.
Okay. So this is the spacing for the distribution bars. Now you cannot provide without checking as per the IS code 300. No, you cannot provide like this. You have to check.
What is AST, sir?
uh,
So what is the AST, sir?
AST is steel. AST is steel. We have calculated here minimum steel 150 mm square. So in this 333.3 or 23 millimeters center to center you have got the spacing. Now you have to check
So
as
where
per.
did we get the 8 mm? Oh,
Yes, at mm we have to assume that which reinforcement we have to provide. Let me finish this. You can provide 6 mm also. Then the minimum spacing criteria is 3 times the depth or 300 mm. So this was the criteria for checking the spacing of main reinforcement. For distribution reinforcement, slight change is there. Instead of 3 times depth, it is effective depth, it is 5D or 450 millimeters. This is the criteria for distribution reinforcement. Now you apply the criteria. Effective depth is 100 millimeters. So 500 and 450. You have to choose minimum of these two. So 450 mm. You can at the most provide 450 mm. But our calculated value is less than 450 mm. So you have to provide the spacing as 300 mm center to center. So the distribution reinforcement you have provided is 8 mm diabars, 8 mm diabars at the rate 300 millimeters center to center. Now this selection of diameter of bars you are free to select. Someone can design distribution reinforcement in one-way slab panel using 6 mm bars also. So that depends upon you. And how to calculate the steel AST I have already explained in my previous lectures. In today's lecture I have just assumed AST for the main steel so that you can understand after the calculation of the steel how to provide the reinforcement. and for distribution steel the criteria has been discussed. So in this way you have to provide the main reinforcement and distribution reinforcement. So thank you very much students, you might have enjoyed the lecture. Thank you.